All right, we will go ahead and get started. I'd like to say welcome to everyone and thank you for joining us for this first session in our three-part series, Code, Collaborate, and Ship Unreal Workflows with Assembla and with Visual Assist. This series is jointly sponsored by Assembla and Whole Tomato, and it's designed to give Unreal Engine 5 developers practical and real-world workflows that scale with your team, your future team, and survive the chaos of real production. So across all three of these sessions, you'll see how to set up some rock-solid project foundations, how to manage your collaborative source control with Perforce, how to implement CI/CD pipelines that understand the realities of game development, and how to boost your C++ productivity with Visual Assist inside of Visual Studio. My name is Ben Schwenk. I'm General Manager of Whole Tomato, the publishers of the quite popular Visual Studio extension, Visual Assist, which we will be covering in our third webinar on Friday. So today in session 1, from zero to hero, we'll walk through building a bulletproof UE5 project setup that can take you from solo prototyping to full team production without drowning in asset conflicts and broken builds 6 months in. And with that, I'm pleased to introduce today's presenters, two powerhouses. And for today's webinar, we have John Scott, who is the Chief Architect of Assembla. He brings over 35 years of game development experience, including 20 years with Unreal Engine, and he's even spent time as a senior programmer at Epic Games. We also have Montana Mendy, our solutions engineer at Assembla, who, in his own words, fixes people's problems with his deep technical expertise and his understanding of the Assembla platform. He's been going for 5 years strong with Assembla and is indispensable for ensuring its users get the most out of it. So John and Montana are going to walk you through the key decisions, the tools, and the setup steps you need to get right from the start with Unreal Engine, with a special emphasis on standardizing on the Assembla code hosting platform. So we'll have time at the end for a Q&A session. So please drop your questions in the chat as we go, and we'll cover as many as possible before we wrap up. With that, let's dive in. John, I'll hand it over to you.
Thank you, Ben, for that very nice introduction. Your first decision when deciding how to develop your Unreal Engine 5 game or utility is to decide whether you want to compile from source or install the binary version and make content. If you just wish to make content, I'd recommend the binary version. It's much easier and less demanding on resources. If you wish to compile from source and change engine code, then that is a much heavier lift to be able to do that practically. For example, if you compile from source code, you will need a very powerful desktop or an incredible farm to be able to compile in reasonable timeframes. If you're a team with multiple programmers and artists, you'll need a small build farm for continuous integration and providing your engine changes to your artists. You should also be familiar with the Perforce branching strategies and be confident in being able to merge your changes from one engine version to the next. Unreal Engine is multiple million lines of C++ code and definitely not for an amateur. If you just wish to make content, such as a game, with faster iteration using existing engine functionality, then using the installed version of the engine is a much easier option. Most features can be extended cleanly, so you aren't completely blocked from C++ coding, but it will not be possible to make fundamental changes, e.g. making a new landscape system. As you can't make changes to the engine, upgrading engine versions is trivial. You just load the project with the new installed engine. Epic are very good at maintaining backwards compatibility with old assets. For reference, I'm running on an old desktop with a fresh install of Windows 11. It's an old Xeon E5 1620 with four hyper-threaded cores, 64 gigabytes of RAM, GeForce Titan X, and NVMe storage. Compile times are very much limited to disk access speeds, so having an NVMe drive is critical. I did start out with a GeForce 970, but that immediately ran out of memory and was overflowing graphics memory just by running the basic editor. Installing the prerequisites. First thing you need is Visual Studio 2022 Community. You can download it from that link there. Make sure to enable the C++ and C# workloads. There are other required features, but those can be installed on demand when you're loading the solution and using the integration checker built into Unreal Engine 5. Install the Perforce client. This is called P4V. It can be downloaded from that link. You don't need the server or any other components. Just make sure you have P4, the command line client, and P4 admin. Also, Visual Studio has a P4VS plugin, so you can seamlessly check out things from within Visual Studio. Install Visual Assist. We'll be demoing this in a third webinar, so install that now. And for completeness, these are the tools I used to make the webinar. So, the first thing you need to do is download the binary version of the engine. So you create an Epic Games account. I'll just go over this quite briefly, as I'm sure this is covered in numerous other locations. Click Sign In, create account, verify your email, then click on Unreal Engine in the left bar and click Install Engine on the top right. Once that's installed, then it will automatically run. Sign in with your Epic Games account. Click on Games, select your preferred game template. Select the project location, project name, and C++. I use the first-person template for this example because I like first-person games. I install it to C-root Epic, not in my local documents folder. There can be some issues with long path names. I also imaginatively call the project sample game, and as I'm a C++ programmer, I use C++ and not blueprints. After several minutes, you should see the Unreal Engine editor running and a new instance of Visual Studio with this project loading. This project will be used for future tests. On first run of Visual Studio, you will see the Unreal integration check here. Run through these, make sure everything's installed properly. When you first load in the solution, it may come up with some things that are missing. So manage those NuGet packages and make sure everything's installed. So, why use Perforce? There are two major reasons. Exclusive checkout, which means you take ownership of the files yourself. No one can edit them until you check them back in. Also, Perforce has spent a lot of time handling, optimizing the handling of large binary files and syncing large binary files over poor network connections and having multiple tens of terabytes repositories. The recommended size limit for a Git repository is 1 gigabyte, and that can be just one asset in Unreal Engine 5. So the exclusive checkout. So if you're editing code, such as a CPP file or anything text, then two people can make different changes at the same time, check them in, and the second one will have to merge in the other person's changes. That is fine. That is a valid way of development. However, if you're editing a binary file, say a PNG file, then that can't be done. You can't merge two PNG files. It just doesn't work. So the way around that is to have exclusive checkout, which basically means I'm going to work on this file, and while I'm working on it, no one else can. Also, the way Git works is every version has a complete history of the entire repo stored locally. And this, if you have a 100 gigabyte repo, that can explode in storage requirements very, very quickly. Anchor points, when they're marketing Git for, they have a product which is marketed as Git for artists, and that aggressively cleans out that history and has exclusive checkout. Still has the regular Git problems, but it is a step in the right direction. There are alternatives to Perforce. Diversion and Plastic have similar functionality. However, these are not used as much at the moment, and neither are supported by Assembla. Good day. Today we are going to sign up for a free account on the Assembla platform and enable a Perforce repo. So we start by going to getassembler.com, start for free. Pick your local region, obviously pick the one nearest to you, and fill in the form. Username, email is going to be user@gmail.com. Password. There we go. Organizational domain. This is also known as your portfolio. This is your company name. This is a container for all your spaces. Each space can be regarded as a project. So let's do the Anduin amalgamated. Okay, I agree to the service. I agree to receive marketing communication. Create account.
And I guess while we're at it, what is the difference between a portfolio and a space?
Think of a portfolio like this. It contains a set of spaces. Each space organizes a project, and each space can have one or more repositories, wiki pages, card walls for tickets, and generally manage a project. So, I can confirm my email address. Boom. Before we do that, let us go to and enable Perforce on this account. Go to Accounts and Billing and Modify Trial Plan. By default, Helix is an add-on, so it does not come by default with the trial, but when you sign up for a trial. So we'll just add Helix Core. Number of users, we'll have 3, me, Montana, and Chris, and we'll all have access to Perforce. And we shall continue the trial. Bada bing. So now let's create a new space. My space name, imaginatively called sample game. Let's call it a prefix of SG. This prefixes all tickets and all links, so it's easy to find where a document comes from. Let's create with the repository, ticket tool, and wiki. Create a new space.
I guess since you're creating a space, can a space be in multiple portfolios?
It cannot. A space can only be in a single portfolio. A portfolio can have multiple spaces, but not the other way around. So I add Perforce, my repository name, sample game repo, create empty repository. Go to, there we go. And this is the server we have created in AWS that hosts your own personal Perforce server. Let's have a quick look at the card wall. Here's a typical Kanban card wall. Let's add a column, shall we? Ready to deploy. And that's add. Okay. So let's create a ticket. Add sample game files to Perforce repository.
Now that you're creating a ticket, what metrics can I see at the portfolio level, like commits, tickets, activity, all that stuff?
There are many different things you can see. The stream here is a detailed log of everything that's happened, as you can see here. We can also view metrics here, which is, well, let's use the new metric dashboard. We can have tickets by status, open close tickets, tickets by priority, any number of different charts you can see. Obviously with one ticket just created, it's not very worthwhile at the moment. These charts are using Fusion Charts, a sister IDEA company. Does that answer your question?
Absolutely, it does.
Let's have the wiki. So let's create a new page. This is WYSIWYG. Hello. Rich text. This is Frawala, which is another IDEA sister company. It is good being part of a large corporate portfolio. Just please document your plans for your awesome sample game here. I can type, honest. Submit. Hello. And we now have an account.
And when you say WYSIWYG, that's what you see is what you get, correct?
That is correct, yes. Now we have a working server, but in the cloud we can connect to it. I would recommend using p4config to set the default settings for this folder. It is, if you're like me and connect to multiple different servers, having a small local config file is very handy when switching servers. So we go p4 client equals, this is the name of the workspace. I recommend using a naming convention. I use machine name, username, and then the project name. P4 port is the server address you can copy from the Assembla page, and P4 user is your Assembla username. Save that. From the command line, p4 config, set p4 config equals p4 config.txt. Now if you go p4 info, okay, we need to trust the fingerprint. So let's do that. Copy the fingerprint. P4 trust -I, and now we trust it. So let's look at P4 info. As you can see, we have the client, the host, client root, and the stream, and lots of details about the server we are connecting to. As discussed earlier, one of the benefits of using Perforce is you get to define which files can be checked out by multiple people and merged after the fact, and which files are exclusive checkout and owned by the content creator. This is obviously because text files can be merged, but binary files cannot be. For example, U assets should always be exclusive checkout. CPP files should be mergeable, unless there's a very good reason not to make them mergeable. Typically, this is done by the type map and defined by each extension. There is a link in the documentation of where to grab the files. Here's one I downloaded earlier. As you can see, CPP files are text and not exclusive checkout. Config are text plus W, which means they are always writable on the client, which means typically you don't control them in the source code, and they can be overwritten by default. Binary means you can check them out, and binary plus L means only one person at the given time can check them out, so only one person can edit them. So now we set the type map. P4.
And is that equivalent to an exclusive lock?
The -L is equivalent to an exclusive lock, yes.
Thank you, John.
After some experimentation, we find how to do this. I'll just go to the previous line. We're not logged in. So what we do is we go to P4 login, type in our password, this is the Assembla password you used. So now we're logged in, set the type map saved. And if we go P4 type map, it comes up with all the settings. It is important to do this before you actually add the files, otherwise all the files in your repo will have the wrong settings for exclusive checkout, text, binary. Perforce does a great job of determining between binary and text, but it has no idea which ones should be exclusive checkout and which ones can be merged. Now we have finished with the command line. Now the type map is set, so we can go to the visual client from Perforce. This is P4V. It is the right port now, and that's from double check 32213, correct. User is your Assembla user and your Perforce user, and a workspace we wish to create a new one. So click on new. So workspace name, we want as we discussed earlier, machine name, the username, and the project name. Let's browse. As we already downloaded the sample game and got it going, here we go. Let's select that folder. Stream wants to be main. Mainline depot main, straightforward enough. Stream at change, that doesn't really matter. And OK. We've already got content in there, so it's just making sure we're not accidentally overwriting something. In this case, we definitely want to use the existing folder. OK. Now,
are the commands in the log section what P4 is actually running?
That is what it's running under the hood, yes. The Perforce visual client uses the same API as the command line client, and it lists what it is doing in the log window, as you can see below. Now for the stream specification. Some of these files do not want to be source controlled. Some things we don't want in a history of. There's lots of temporary files, and we don't want to control those. The way you do that is set up the stream specification. Let's go to streams. this one here, and we can edit the stream. Go to advanced and ignored. So for example, the VS folder is all the temporary files used by Visual Studio. So let's lock that one out. So the ... means every file and folder recursively under that folder. Intermediate is all the temporary files, the compiled object files before they are linked, the generated project files. So we definitely do not want to source control any of those. The derived data cache, this is the Unreal Engine processes each asset and converts them to a ready to render form. This can take up quite a bit of memory and takes a bit of time, but it's all stored in the derived data cache. At any time you can delete that entire folder and it will automatically regenerate it all. It will just take some time. And finally, saved. We don't want to store any of those. That contains save games, logs, crash dumps, things that could be useful in the short term but don't need to be stored for the long term. So we'll apply that. Oh. Okay. So now we can add all our files to source control. So we just add them here. That took a little while, but as you can see in the log here, there were many files opened. And they're all in the pending change list, ready to go. As you can see, the U assets are binary and exclusive checkout. The JSON files are always writable. The U project is text that can be merged. So let's submit this. Added initial code and assets for sample game. And we shall have ready to deploy H1. Submit. This, depending on your internet connection, could take a little while. And we're done. So if we go back to Assembla now, all the source will appear in here. Source. And you'll notice it doesn't have the intermediate folder or the derived data cache folder or the VS folder. Also, if you go to the card wall, ticket number 1 has been moved to ready to deploy due to it passing the check in the submission message. So that's one little shortcut you can do. Good day, everyone. Just going over some of the less common Perforce client settings that you set in P4V. Let's start off with choose character encoding. This should be UTF-8. Everything on the Perforce server is stored in UTF-8. So using UTF-8 locally means there are no translation errors, very slight performance improvement on the server, and just fewer chances of error. There are many options here. UTF-16 is very, very rarely parsed correctly. It's either 2 bytes or 4 bytes. It's also very difficult to auto-detect. UTF-32 is a waste of memory, and the rest are you're at the mercy of the local client code page, which is not what you want, especially if you're working with a multinational team. If you wish to go into greater detail on this, go to utf8everywhere.org, and that will go over the reasoning and how to best practices to make this less of a problem. Now to go to the workspaces, let's view workspaces. Let's go to properties, edit workspace. Where's that got? There we go. Advanced. So all write means when you sync, every file on in your local hard drive is writable. It's by default it's read only, which means you can't accidentally overwrite something without checking something out. That is, I would leave that as is. Clobber, this means it will sync even if Perforce thinks there's been a change on the client. Be careful with this. Sometimes it's useful. It's useful on build machines, but it's not useful for working with a client. Typically, you might lose some changes. Compress, this puts a very large load on the server, and this will you will need a much more performance server to get the same speed. So I'd recommend not using this. Mod time, this sets when you sync, it sets the timestamp of that file to the server time when the file was submitted. You should almost never use this. I would not set it unless you really, unless you have something like a binary only build which you're syncing without source files, and somehow it detects that the binary files are out of date and wants to recompile them, but there are no source files to recompile, causing a problem. Generally speaking, you want anything you sync and changes, you want to be marked as out of date, so your local compiler will recompile it. RMDIR, this removes workspaces, this removes folders when the folder becomes empty. By default, it does not do this, so I'd recommend setting this. Otherwise you end up with folder trees full of empty files all over the place. Defaults to current system. On submit, I would revert unchanged files. This would simplify the revision history. If you thought about changing a file but didn't actually make any changes, then it will just revert it. So it will keep a cleaner version history of the files. So now we shall hook up the Unreal Engine 5 editor directly to the Perforce server, so you can use it from within the editor. So let's start by going and opening up the U project. It's currently set to open by Notepad currently, so open with Unreal Engine. And give it a couple of seconds to actually open. There we go. And now we go to Tools, connect to Revision Control, select Perforce. In theory, we should be able to use the P4 config we created earlier, but it seems that there are issues with that currently. So the best bet is to go back to your assembler, copy the server address, type that in, your assembler user, your workspace, and then pick the available workspace, which is the one we created in the Perforce client earlier. Okay, accept settings. Successful. And that's it. So now we shall do a sample content change. Let's go to just add some 3D text, which is in a plugin. So we go to the plugins, which is here. Search for text 3D. Oh, there we go. It's a beta version, but it will work in this case. We need to restart the engine for that to happen. So let's restart. Oh, my project file is out of date, so let's update that. Might as well. Okay, so now we can go. What we need to do is place an actor. So we go open up the Place Actors tab, search for text 3D. Here we go. Drag and drop. There we go. Let's click on Rotate and spin it around so it's facing us. Let's click on the scale so we can make it a bit bigger. And if we select, and then on the movement, back to the movement, which is that one, we should go to click on here, and we can pick the font. Let's have barn shrift, whatever that is. And the text is, where is the text gone? Oh, there. Cunningly hidden under text. So let's have hello, Donna. Click away.
Oh, thanks, John.
We should have that. As you can see, it's a nice shadow there. So let's File, Save All. And everything is checked out. So if we go to the View Changes, here we have all the content was changed with adding that asset. You can see the font and the 3D actor with the properties, scale, and contents of the text. Double click on this, just add a comment, added sample content, change, submit. And now it's on the common server in here. If we look at commits, you can see added sample content change there. And we can see the files that were changed here. And we can even look at the files. That's binary, so we can't tell that. What changed in the U project? Oh, it added the tool.
Welcome to the Assembla tutorial on how to really pull and sync a repo that's already been up, kind of maybe been messed with a little bit, and you want to kind of bring it down and play with it on Unreal Project Browser. So we're going to do that. So let's do p4 sync -f. Really easy. And we've even made it easier is I've made a regen script, which I will attach here somewhere here. So let's see here. Okay, so let's run the regen script. And you'll see here that is discovering all the Xcode project files. And the reason for that is this is on a Mac OS device, obviously. So you will need Xcode. And this is going to act like any other builder. So it's going to be building 30 actions right now. It's going to be kind of right now doing shared PCH and CPP20, C++20, and we'll get through this, and then we'll kind of show you what you do next here. It is worth noting that on some cases you may need to change the workspace once, but I've only run that run into that like once or twice, so should not be an issue. All right, so you can see now, you can now open the project in Unreal Editor, open the Xcode workspace. So, all right, well, we have the Unreal Editor open. So let's do this. I think this is it here. So it's going to open this. Ah, here we go. Looks like it's going to open. I know my colleague John Scott did a great little game for me here. And as you can see, hello Montana. And we'll kind of go in on the other way. So let's look up at it. It's kind of cool. And you'll see in the right hand corner here, revision control. This is all to do with the mainline branch in Perforce. So you can, one of the good things about if you're running Assembla and the Unreal Engine, you can go direct, basically EDE, and not really have to move out of that ecosystem. So that is just one of the very many things you can do with Assembla while using UE5. I hope you enjoyed this.
Hello, I hope you enjoyed that. Thank you very much. Now we're open for any Q&A you may have. There we go. The recordings will be made available later on. I'm not exactly sure where, most likely on YouTube. Watch your email for the actual location. Are there any other questions? So I have one here. What branching strategy in Perforce works best with Assembla's sprint-based workflow? My personal solution is we have mainline development, which is where you build, your build machine builds your releases from, and where the artists compile the editor and run the editor to make their assets. And then if you're working, then you have your own personal branch off that, which is merged down in a development branch. It's called in Perforce, which you do your personal work in. And then once you've actually completed the feature, you copy back up to the main for everyone to use, for your artists and other programmers to see. It is the merge down, copy up strategy, which is documented in Perforce in a lot of locations.
How about I get the next one, John, which is the what are the trade-offs or benefits of using stream specs to ignore files instead of p4ignore? Or if you want to get it, I can get it. It's up to you. I'll take a stab at it. And
Okay.
So I think some of the we'll do some trade-offs and benefits here. So the benefits, I think, centralized control, obviously for the team. It's version controlled, access controlled, really easy to control access, role-based access control. There's inheritance, and then some of those trade-offs, a little bit less flexible, so a little bit less agile, and it's more difficult to exclude generated file easily. And it's path-based only. So stream specs that are using like depot path patterns, which can be like more complex to configure sometimes, right? Than the simple like file name patterns. But the p4ignore client side ignore, I think the benefits there are the generated files, no permissions needed sometimes, can be versioned. Those are kind of the main things. And best practices, I mean, if you're using stream specifications, when you want to permanently exclude directories, things like that, etc. So obviously there's going to be pros and cons with everything, but those are kind of the main points. I don't know if you have anything to add to that, John, but.
That sounds great. Thank you. Also, question here, I'm wondering what Assembler adds to the workflow compared to only using Unreal with Perforce. We have a ticketing system to replace Jira, a wiki system to replace Confluence, and if you want to use Git and Subversion as well, we can do that. We're also very reasonably priced, and we will manage your server, Perforce server for you, which will saves a lot on DevOps expenses. Anything to add there, Montana?
Okay. Oops. So the one that says you mentioned P4 Visual Studio or P4 V6 for Visual Studio, is there any feature similar to Git Blame in the IDE? I'm pretty sure there's just a Blame tab, if I'm not mistaken. So you actually, if my memory serves me correct, so you want to go to source control, time lapse view, and that would actually be the equivalent of Blame. So as far as I think some of just the advanced solutions you were kind of talking about, I mean, there's everything you can go from lightweight solution load to the manual checkout workflow, and that really all goes to P4 VS. And I think some of the best practices that I've seen is keep Visual Studio purely for coding, keep automatic P4 integration minimal or disabled, and then consider VS Code with Perforce extension as a lighter weight alternative. So I think those are a couple things to keep in mind. And that was a great question about P4 Visual Studio.
Regarding the pausing, I've only ever seen the pause when linking, when it's basically the computer can't swap memory out to disk because the linking process is completely hogging all the disk access. The only time I've seen the hang. Are there any additional settings we should enable to optimize syncing speeds for large projects? You can enable parallel sync. Some people, when that feature was initially released, it was not the most reliable thing in the world. They have done, Perforce have done a lot of work on it now, and it can help a lot with your syncing speeds.
Well, I also think just, caching files, locally or regionally, and parallel sync, and I think some network tuning, depending on your thread counts, and optimize, client workspace. I think all these things are really on your way to really help, sync speeds. So, and compression settings as well. I shouldn't leave that out, but yeah.
Do we have any more questions? Can Assembla automatically track Perforce submissions related to UE5 asset changes? Yes, it can. That appears in the commit tab in the repo. We'll list all changes there. You can also view all files in the repo if there's a previewer installed. So you can view ping files, you can't preview USF files. We can use Perforce DAM to do that, which is a feature we offer for single tenant users, but not in the cloud solution. Is there anything else? I think we're good. Should we just say a thank you for bearing with us and watching all this?
Thank you.
Okay, there's a new question here. Okay, so will the other seminars go over how to upgrade Unreal Engine source built in Perforce? The second webinar will go into some of that, not in great detail though, but it will have some recommendations. But okay, back to thank yous. Thank you for watching us. This video will be made available later. Watch your email. Thank you very much.
Thank you.